Look at the map of the East Coast of the United States. Now, I want you to burn it. Erase Philadelphia. Erase Baltimore. Turn Washington, D.C. into a crater of radioactive glass. This isn't a scene from Fallout. It isn't a hypothetical scenario from a sci-fi novel. This is exactly what should have happened on a Tuesday morning in January 1961. By all laws of physics and probability, the state of North Carolina does not exist today. Millions of people you know, your parents, your favorite musicians, maybe even you, should never have been born. The global economy should have collapsed 50 years ago. The Cold War should have turned hot, ending human civilization before the Beatles even released their first album. We are alive right now. You are watching this video on a screen that exists. But here is the paradox. We aren't here because of brilliant diplomacy. We aren't here because of advanced safety protocols or the genius of the Pentagon. We are here because of a single 50-cent switch, a cheap, low-voltage toggle, the kind you'd buy at a hardware store to turn on a desk lamp. It decided against all odds not to close a circuit. This is the Mark 39 hydrogen bomb. It is not Little Boy that dropped on Hiroshima. That was a firecracker compared to this monster. The Mark 39 had a yield of 3.8 megatons. That is 3,800,000 tons of TNT. To put that into perspective, if you took all the explosives used in World War II, every grenade, every tank shell, every V-2 rocket, and the atomic bombs dropped on Japan, and piled them up, the Mark 39 is still larger. If it detonates, the fireball alone is 2 miles wide. The thermal radiation causes third-degree burns 20 miles away. The fallout rides the jet stream north, poisoning the entire eastern seaboard. On January the 24th, 1961, two of these monsters fell out of the sky over Goldsboro, North Carolina. A farmer standing in his field looked up and saw white silk, a parachute, drifting down gently, carrying a metal cylinder the size of a minivan. It looked peaceful, but inside that cylinder, a mechanical brain was waking up. It was clicking through a checklist. Arming wires, pulled, barometric switches, active, batteries, charged. The bomb didn't just fall, it was trying to fire. It went through every single step required to initiate a thermonuclear sun on American soil. It completed 6 out of 7 steps. 6 out of 7. So, why are we still here? How did the most dangerous weapon in human history fail to do the one thing it was designed to do? And why, for 50 years, did the government lie to your face and tell you that you were never in danger? Today, we are going to dissect the single most terrifying near miss in human history. We're going to look at the engineering of the B-52 Stratofortress, a plane that was falling apart before it even took off. We will go deep into the mechanics of a nuclear weapon to understand how a quote one system actually works and how, on that day, every single safety mechanism failed except one. We're going to dig into the swamp where one of the nuclear cores is still burying itself deeper into the mud right now. As you watch this, yes, it's still there. And we will expose the quote 2 incidents, the secret list of times we accidentally dropped hydrogen bombs on our own allies. You think the world is held together by treaties and technology? No, it's held together by luck. And on January 24th, 1961, luck was the only thing we had left. There is a myth we tell ourselves to sleep at night. The quote 3. We like to believe that nuclear weapons are under strict godlike control. We imagine a room full of serious men in suits, dual-key systems, retinal scanners, and unbreakable codes. We think that for a nuclear weapon to go off, the president has to open a briefcase and type in a launch code. That is a lie. In 1961, there were no permissive action links. There were no coded locks on the bombs themselves. If you could physically get into the cockpit and flip a switch, or if the bomb thought you flipped the switch, it would detonate. It was analog, it was mechanical, it was stupid. The United States was terrified of a Soviet first strike. The logic was simple. If the Soviets nuked the airfields, the American bombers would be destroyed on the ground. Therefore, the Pentagon came up with a solution. Operation Chrome Dome. The idea was to keep a fleet of B-52 bombers in the air, 24 hours a day, 7 days a week, circling the borders of the Soviet Union, loaded with nukes, ready to drop them at a moment's notice. It sounds impressive. A chrome dome of protection, but in reality, it was a logistical nightmare. It meant taking machines, aircraft, and pushing them beyond their limits. Enter Flight 53-0394. This B-52G Stratofortress wasn't a marvel of futuristic engineering. It was a workhorse. And like any workhorse that's been ridden too hard, it was tired. On the night of January the 23rd, the crew, led by Major Walter Tulik, took off from Seymour Johnson Air Force Base. Their mission was a standard 24-hour patrol loop, routine, boring, but midway through the flight, a refueling tanker crew noticed something disturbing. They radioed Tulik. "Sir, you have a leak. Your right wing is bleeding fuel." This wasn't a drip. It was a hemorrhage. The B-52 is a wet wing design. The fuel is stored inside the structure of the wing itself. If you lose fuel, you lose weight. If you lose weight unevenly, the plane becomes unbalanced. Major Tulik was a pro. He didn't panic. He contacted ground control. They told him to enter a holding pattern off the coast, to burn off excess fuel before attempting a landing. Standard procedure. Therefore, he turned the plane. But standard procedure assumes the plane is structurally sound. It assumes the metal isn't fatigued. It assumes the laws of aerodynamics are on your side. As they descended to 10,000 feet, the turbulence hit. The fuel leak had compromised the structural integrity of the wing. The giant bird groaned. And then it snapped. The right wing didn't just bend, it sheared off. Imagine being in a washing machine tumbling down a flight of stairs. The fuselage went into a violent, uncontrollable spin. The G-forces were instant and brutal. They pinned the crew to the walls. Major Tulik shouted the order, "Bail out! Bail out!" 5 men managed to eject. 3 didn't. They died in the wreckage. But we aren't here to talk about the tragedy of the crash. We are here to talk about what happened to the cargo. The centrifugal force of the spinning plane acted like a giant hand. It reached into the bomb bay. The force was so violent that it ripped the bomb bay doors open. It tore the racks apart. And it threw 2 Mark 39 hydrogen bombs into the morning sky. They were falling, free, no pilot, no codes, just gravity and mechanics. This is where the horror story begins. We have 2 bombs falling over North Carolina. Let's call them Bomb A and Bomb B. They are identical twins, same yield, same circuits, same mission. But as they fell, they took 2 very different paths. Bomb B fell like a stone. It had no parachute. It tumbled through the air at terminal velocity, nearly the speed of sound. It hit the ground in a swampy field off Big Daddy Road. It hit the mud at nearly 700 miles per hour. The impact was cataclysmic. The bomb disintegrated. It didn't explode, it shattered. It buried itself 50 feet deep into the muck. The tail section was found sticking out of the mud like a tombstone. Why didn't Bomb B detonate? Because it fell too fast. The impact destroyed the circuitry before the electrical signal could travel to the detonators. It was a kinetic kill. The physics of the crash murdered the bomb before the bomb could murder the state. Pure dumb luck. But Bomb A? Bomb A is the reason I can't sleep at night. Bomb A didn't fall like a stone. When the plane broke apart, the lanyard attached to the aircraft snapped. This lanyard is like the ripcord on a parachute. Therefore, Bomb A thought it had been released by the pilot. It thought the mission was a go. Let's look at the checklist of death that Bomb A executed on its way down. Step 1. The arming wires. When the bomb was ripped from the plane, the arming wires were yanked out. This is the physical equivalent of taking the safety off a gun. Status passed. Step 2. The pulse generator. As the bomb fell, the airflow spun a small turbine in the nose. This turbine is an electric generator. It powers the bomb's internal battery. The bomb woke up. It had power. Status passed. Step 3. The parachute. Because the lanyard was pulled, the bomb deployed its 100-foot parachute. This is designed to slow the bomb down so the plane can fly away before the explosion. The parachute caught the wind. The bomb stabilized. It was drifting down gently, exactly as if it were over Moscow. Status passed. Step 4. The barometric switches. These sensors measure air pressure. They are waiting for a specific altitude to trigger the firing circuit. The bomb sensed it was falling. It sensed the pressure rising. Status passed. The bomb was live. It was armed. It was descending toward the target. The firing capacitors were charging up, ready to send a high-voltage jolt into the explosive lenses that would compress the plutonium core. There was only one thing left, one final gatekeeper. Inside the bomb, there was a panel. On that panel, there were 4 safety switches. For the bomb to detonate, all 4 had to flip to quote 6, switch 1 and 2. These were pulled by the physical lanyard when the plane broke up. Status, armed. Switch 3. This was the barometric prearm. It activated when the bomb detected the altitude drop. Status, armed. 3 out of 4 gates were open. The current was flowing. It was racing toward the detonator. It hit the final switch, switch 4, the cockpit arm/safe switch. This is the only thing that saved the world. Let me explain what this switch is. It isn't a digital code. It isn't a biometric scanner. It is a simple physical toggle switch located in the cockpit of the B-52. The pilot is supposed to flip the switch to quote 7 before dropping the bomb. Since Major Tulloch never flipped the switch, the signal should have been blocked. However, remember the breakup? The plane disintegrated in midair. High-voltage cables were snapping. Sparks were flying. The electrical system of the B-52 was melting down. There was a massive risk that a stray electrical short could have bypassed the switch, or that the shock of the breakup could have jarred the switch into the quote, _8 position. The bomb landed. The parachute draped over a tree. The bomb stood upright, its nose buried in the ground. The Explosive Ordnance Disposal, EOD team arrived. They approached the alien object with trembling hands. They knew what they were looking at. They saw the parachute. They knew that meant the arming sequence had started. Lieutenant Jack Revell, the man responsible for disarming it, later described looking into the access panel. He saw the 4 switches: 1, arm; 2, arm; 3, arm. And the 4th, safe. But here is the kick in the gut. When they analyzed the switch later, they found something that made their blood run cold. This specific type of switch, the precise model used in the Mark 39, had a known defect. In testing, it had a failure rate. It was prone to quote 9 or engaging on its own during high G-shocks. Later, Secretary of Defense Robert McNamara admitted that on other bombs, this exact switch had failed in the quote 10 position during tests. If the plane had broken up a few seconds differently, if a stray spark had jumped a quarter of an inch, if the switch had been manufactured on a Friday afternoon by a tired worker, the circuit would have closed. The firing signal would have reached the lenses. The conventional explosives would have detonated, imploding the plutonium pit. The fission reaction would ignite the fusion fuel. A fireball hotter than the center of the sun would have consumed Goldsboro. The shock wave would have flattened everything within miles. The radiation would have killed thousands instantly and millions slowly. And the Soviets? Their radar would have picked up a 3.8 megaton detonation on the U.S. East Coast. They wouldn't know it was an accident. They would assume it was a first strike launch that malfunctioned, or a civil war, or a test. They might have launched a retaliatory strike, the end of the world, prevented by a toggle switch that was known to be defective. Now, you might be thinking, wow, that was close, but surely the government learned from this. Surely they told us the truth. No, they lied. For decades, the official line was, there was never any danger of a nuclear explosion. They treated us like children. They said the safety systems worked exactly as designed. They patted themselves on the back. But in 2013, a journalist named Eric Schlosser used the Freedom of Information Act to uncover a secret document written in 1969. It was a classified report by Parker F. Jones, the supervisor of nuclear weapons safety at Sondia National Laboratories. Jones didn't mince words. He wasn't writing for the public. He was writing for his bosses. The title of his report? Goldsboro Revisited, or How I Learned to Mistrust the H-Bomb, a dark reference to Dr. Strangelove. In the report, Jones wrote a sentence that should be engraved on the tombstone of human arrogance. One simple dynamo technology, low voltage switch stood between the United States and a major catastrophe. He concluded that the Mk-39 Mod 2 bomb did not possess adequate safety for the airborne alert role. He basically said the bomb was a death trap, but it gets worse. We didn't just almost nuke North Carolina, we made a habit of dropping these things. 1966, Palomares, Spain. A B-52 collided with a tanker. 4 hydrogen bombs fell. 2 of them didn't explode nuclearly, but the conventional explosives did go off, scattering radioactive plutonium dust all over the Spanish countryside. We had to scrape up tons of Spanish soil and ship it to South Carolina to bury it. 1968, Thule, Greenland. Another B-52 crashed on the ice. The bombs broke open, radioactive contamination everywhere. We were playing Russian roulette with the planet, and we just kept pulling the trigger, assuming the gun was empty. And what about Bomb B, the one that slammed into the swamp? The Air Force dug. They brought in heavy equipment. They pumped water out of the crater. They found the tail. They found the parachute pack, but they couldn't find the secondary core. The underscore, quote, underscore 11, underscore the heart of the thermonuclear device, containing the highly enriched uranium and plutonium. The swamp was too deep. The water table was too high. The core had burrowed itself 50, maybe 100 feet down into the liquid earth. Eventually, the Air Force realized they couldn't recover it without digging a hole so big it would destroy the local water supply. So, do you know what they did? They gave up. They bought the land from the farmer. They paid him for his silence and his dirt. They filled the hole with concrete, and they left. Today, if you drive down Big Daddy Road in Faro, North Carolina, you will pass a nondescript field. There are trees, there are crops. It looks like anywhere else in America. But beneath the roots of those trees, encased in mud and concrete, lies a thermonuclear warhead. It is still there, waiting. The government still owns the easement. The deed restricts digging below 5 feet. You can farm the surface, but you cannot dig a well, because if you do, you might hit the most dangerous object ever created by man. We like to think we are the masters of our domain. We build artificial intelligence. We smash atoms at the Large Hadron Collider. We land rovers on Mars. We construct complex narratives about history. We say the Cold War ended because of economic pressure, or democracy triumphed over communism. But the story of Goldsboro tells us a different, more uncomfortable truth. History is not a straight line. It is a chaotic scramble. It is a series of coin flips. If that switch had shorted just a microscopic spark, 1961 would have been the last year of recorded history. There would be no internet, no moon landing, no you. We often talk about the great filter in astronomy, the reason we haven't found aliens yet. Maybe civilizations destroy themselves before they can travel the stars. Goldsboro suggests that the great filter isn't some grand cosmic event. It's not an asteroid. It's not a plague. The great filter is a bad solder joint. It's a tired pilot. It's a leaky fuel tank. It's a bureaucratic decision to save money on a switch. We survived the 20th century not because we were wise, but because we were lucky. And luck is not a strategy. Luck runs out. The weapons are still here. The systems are more digital now, but they are still built by the lowest bidder. They are still operated by humans who get tired, who make mistakes, who have bad days. The farmer in Goldsboro went back to plowing his field. The Air Force went back to flying. The world kept turning. We forgot, but the ground remembers. So, the next time you hear a politician or a general talk about surgical precision or fail-safe security, I want you to remember the swamp. I want you to remember that the only reason you are breathing right now is that a 50-cent piece of metal refused to do what it was told. We are walking on a tightrope over a volcano, and we've convinced ourselves that the rope is a bridge. It's not. Sleep well, and hope that tonight all the switches hold.